This is a picture of an isolation relay which has a 24-volt coil, would have two contacts shown here where you would attach the power to the 24-volt coil. And then you're going to have normally open and normally closed contacts that you would attach your load that you're trying to control with the isolation relay. This is another type of relay that could be used. This one also has a 24-volt coil, and the wiring diagram is outlined in the plastic of the relay with normally open and normally closed contacts, showing the appropriate places where you would land the wires for your particular application. So this is a wiring diagram or actual layout of a control relay or an isolation relay. And you have your 24-volt coil. The coil could, of course, be other voltages depending on what your application is. And then you will have a normally closed contact and a set of normally open contacts. And depending on the application and what you're trying to control, you would want a normally closed or a normally open contact to control the device that you're trying to work with. There are, of course, different types of relays. This is a single pole, single throw relay, which only has a single set of contacts that is normally open, and when the coil is energized, this contact would close. So here you have a double pole, double throw isolation relay that has two different sets of contacts. One is normally open, the other one is normally closed. So when this coil is energized, the normally closed contact will open and the normally open contact will close. So you can control multiple devices by using a relay like this. So you may be asking by this point, where would I apply an isolation relay? Well, let me give you a couple of examples. So this is an application which I'm very familiar with, as I used to do service work in the East where boilers are very prevalent. We have a transformer that is connected to the thermostat strip for W1 for a call for heat, and the other side is connected to the common terminal, and it is run through the coil of the isolation relay. When there's a call for heat, the coil is energized, closing the contacts on the isolation relay, therefore providing power to the boiler or the system that we are trying to control. Therefore, the load is not being imposed upon the transformer, but is controlled through the isolation relay. This is another application of an isolation relay. A number of years ago, we had a thermostat situation where when the thermostat would energize the reversing valve, the backfeed and load from the reversing valve was overheating the thermostat. The resolution to the problem was to put an isolation relay between the R terminal and the reversing valve terminal so that the reversing valve would be isolated from the thermostat, and this resolved the overheating situation. Another application is the application of a low ambient kit on a heat pump. With the advent of inverter technology, this is not something that we do too often anymore, but on standard heat pumps you may still have to apply a low ambient kit. When you do so, you will have to apply an isolation relay to take the condenser fan out of the circuit when we're in heating mode. This is very important. A number of years ago, we had a contractor who installed 8 heat pumps on an office building, and 5 out of the 8 compressors on these units failed within the first year. We found the problem was that when the installers put the low ambient kits on the heat pumps, they did not put the isolation relays in. So therefore, the condenser fan was not running all the time when it should have been in the heating mode. And this eventually took out the compressors. So it's very important to follow the directions on the kits And this is another application where an isolation relay is very important. So isolation relays have many ways to isolate either the power side or the control side of any electrical circuit. These relays can also be used to illuminate lights or LEDs to alert or warn of circuits being energized or failures of devices.
Go to arefco.com for more videos. Like, subscribe, and check back every week for new videos.